So we are going to analyze graphs and talk about domain and range of quadratic functions. So for this first one, x squared plus 6x plus 8, I want to show you two different ways to do it. So one way, follow along with me, go ahead and click your y equals in your calculator. Go ahead and do that. Click your y equals in your calculator and let's type it in. X squared plus 6x plus 8. Y equals 6x plus 8. And hit graph. Hit graph. If your graph does not look like mine, you want to hit zoom. It's the middle gray button. You want to hit zoom 6. And that will make your graph look like mine. Okay. All right, here's what I want to show you. For the vertex is at the bottom. Okay, it's the minimum. Good. You could count -1, -2, -3. It looks like it's at -3, -1. Okay? You could also go to second trace. We did this the other day and go down to minimum. Some of y'all already know how to do that. Okay? And you could do those things. Another thing you're going to have available on the benchmark and the final exam is this Desmos. On your computer right now, let's go ahead and type in, so click here. We did this yesterday. We practiced this. You're going to type in x. And remember, if you hit shift 6, that's how you make it up high. X squared, what else is it? Plus 6x, thank you. Plus 8. Okay, here's the thing I love about Desmos, and you can use the calculator or Desmos, whichever one you prefer, but here's what I love about it. Go over and click the point that is the minimum. Click it. Does it tell you what it is? I think that's pretty easy. I think Desmos is nice for that feature, okay? On the calculator, you can't just click on it and it work, okay? So you have options. So let's go ahead and write down the answer. What is the vertex? Good, -3, -1, okay? Your axis of symmetry, how does that start? Anybody remember? It's always, very good, x equals. It's always x equals. And it's x equals h. Remember, your vertex is h and k. All right, h and k. So what number is your h? The first one, which is -3. In the vertex, okay? And let me explain that a little bit more. On the graph, your axis of symmetry is what cuts it in half. So it's going to go through the middle. It's going to go through -3. Okay? It's going to go through -3. All right. The x-intercepts, once again, you can kind of look on the calculator, or if you use Desmos, you can just click them, and it tells you what they are. So what are they?
-4, 0, -2, 0.
All right. So that is nice about Desmos. It just gives you the coordinates. Okay? All right. Questions? All right, so my x-intercepts -2, 0, and -4, 0. It doesn't matter what order you write them in. Those are my x-intercepts. And my y-intercept, if that's where it crosses the y. So I'm going to click the zoom out on Desmos. It's over here on the side. It's the negative. And then I'm going to click where it crosses the y. Where does it cross the y? 0.8. All right, crosses the y at 0.8. Okay, let's go ahead and do a rough sketch of the graph. It goes through -2 and -4, and the vertex was -3, 1. So I'm just plotting my points. So take your time and do that. Plotting the points and drawing the graph. We already wrote the points down. Those are the points I just plotted, the ones that we're writing down. Okay, for domain and range, that's my fault, he only had half of it. Okay, this is one thing about this class that is confusing, and I don't know how to get around it. We did domain and range in Unit 1 where we had a pre-image and a image. Domain was your pre-image and range was your image, okay? Do we have a pre-image and image? No, okay? Domain is left to right in this case. It's your X values, and you do it in order from left to right, okay? And I know it can be confusing. Let's do a few examples and see if you'll get the hang of it. So, on the left side of this parabola, does it go forever on the left? Yes, okay? That's called negative infinity. If it goes forever on the left, it's going to go to infinity. That means forever. And since it's on the left, it's going towards negative infinity. Okay? On the right, does this parabola go forever?
No.
Yep, we got an arrow here too. It goes forever. That's positive infinity. Okay? Negative infinity to positive infinity. Sometimes they write this as all real numbers. Okay? I don't care which one you do. Okay? Sometimes they write that as all real numbers. All right. Range is your Y values. Range is your Y values. And for this one, you go bottom to top is the order you go in. You go bottom to top. Does the parabola go forever on the bottom? No, it stops. What point is it at the bottom? Okay, I don't know. It gets confusing. You got to give the Y value for this one. What's the Y value at right here? What's the Y value? -1. -1. And they're going to use a bracket, but again, it's going to be multiple choice, so you'll be okay. And then at the top, does it go forever or does it stop? Goes forever. And so parentheses, I'm sorry, infinity, and then a parentheses. It's not a huge deal, but I will explain this real quick. Infinities always get parentheses. Your number values get brackets unless it's an open dot. Did y'all ever see open dots in Math 1?
I think so.
You're supposed to, but anyways, it's not a huge deal. Sometimes they'll put an open dot on a graph, which means it's everything but that number, and then you would have to use a parentheses, okay? It's not going to be a big deal in this class. Yeah, yeah, okay. Okay, let's do number 2. Let's do number 2. Oh, I'm sorry, I forgot to say this about number 1. Without using the calculator, what's the one thing I knew about this? The y-intercept was 8, okay? The y-intercept was 8, and I forgot to point that out. 8's your y-intercept, okay? All right, on number 2, what do I know before I graph it? What do I know? The x-intercepts, good. These two numbers are your x-intercepts. Those two numbers are your x-intercepts. Is it -4 or +4? +4, very good. So we'll write those down for our x-intercepts. 4, 0. What would be the other one? -2, 0, good. Okay. All right, once you have that written down, please type this one into Desmos or your calculator, which one you think you would prefer on the benchmark. So go ahead and type it in. Negative parentheses x minus 4 parentheses x plus 2. So either type it in your calculator or Desmos. I prefer Desmos, but you know, not everybody does. Okay. Type it in y equals or in Desmos. Okay, and this time my vertex is at the top, right? Your vertex is here at the top. What point is that? 1, 9. Okay, 1, 9. So let's write that down. Vertex is at 1, 9. Axis of symmetry is always x equals. And what number are we using? The 1. It's the first part of your vertex. Okay? All right, the y-intercept, let me go back and look at the graph for this one. The y-intercept is where it crosses the y. Where's it crossing? 0, 8 again. 0, 8. Okay, let's graph. 4, 0, negative 2, 0, 0, 8, and 1, 9. All right, go ahead and take a minute and graph it. You can look on your computer screen too for how it's supposed to look. All right, y'all ready?
Yes.
Okay, domain is left to right. Okay, domain is left to right, and you're concentrating on x. On the left, does the parabola go forever? Yes, that's called negative infinity. Okay. On the right, does it go forever? Yes, that is positive infinity. Okay. Another way they might write that answer. All real numbers, okay? You don't have to write both, I just want you to hear it, okay? Domain is left to right. I'll say that a lot. Range is bottom to top. You always have to go in that order, bottom to top. On the bottom, does the parabola go forever? Yes, okay? What is that called if it's going to the bottom forever? Negative infinity, okay? On the top, does it go forever? Okay, where's it stopping at? You got to give me the y value this time. Negative 9 or positive 9? Positive 9. Okay, and this one will be a bracket. Again, don't lose sleep over that. Okay, number 3, sketch the graph of 2 parentheses x minus 3 squared minus 9 over the interval 0 to 6. Let's go ahead on our graph and mark that off. If x is 0, that's going to be here. If x is 0, that'd be right down the middle. How would I mark x being 6? Good. Go over 6. 1, 2, 3, 4, 5, 6. Okay. So I'm only graphing it in that interval. Okay. All right, let me type it in Desmos real quick. Please type it in your calculator or Desmos. All right, what's one point it looks like I should put on my graph? One zero, good. 1 0. Well, if I look, it's not exactly 1, but close enough. All right, 1 0. 5 0. 0 9. 1 2 3 4 5 6 7 8 9. And what's this point? 3 negative 9. 1 2 3 4 5 6 7 8 9. Okay. For this one, if you graph it, kind of looks like that. And what is the question asking on this one? What is the range? That's my key word. When I see range, I'm going to write bottom to top. Whenever I see that, I'm going to write bottom to top. And you might even want to add a note to yourself that it's going to be the y value. Okay? All right, so look at the bottom of your graph. Does it go forever, or is there a point? There's a point. What's the y value of that point? Negative 9. All right, and here's where you have to be careful on this one. At the top, it doesn't go forever on this one because they were cutting it off. They were cutting it off on the left and the right. So where does it stop at the top on this one? It stops somewhere. Where does it stop at? Not negative 9, but it stops at the positive 9 on this one. Stops at the positive 9. It doesn't go forever because to go forever, does it have to cross the boundaries we set? Yeah. Okay. All right. number 4, compare the function negative x plus 2 to the function graph below. All right, so I have this one, and then I have this one in the graph. Are these the same thing? Not necessarily. Okay, so we have 2 different things going on. What do you think I should do with the one in the box? All right, let's graph it. Put it in your calculator or Desmos. Type it in negative x plus 2. Type it in Desmos or your calculator. Negative x plus 2. All right, and let's look at answer choice A. Both functions have the same maximum value. If you look on this one, does this one have a maximum?
No.
All right, it doesn't have a maximum. So can A be true? No, A is not true. Okay, A is not true. Both functions have the same domain. Domain is left to right. Okay, domain is left to right. Okay, this one, and domain is also your x values. Where does this one start? It starts at 0 and goes to infinity. Okay. All right, 0 to infinity. What about the one on the graph? Good. Infinity on both sides. It goes to infinity that way, negative infinity, and positive infinity this way. Okay. So B does not work either. Okay. Both functions have a y-intercept of 2. Let's look at this one first. Does it have a y-intercept of 2?
Yes.
Yes. All right, let's look at the graph. Y-intercept of 2?
Yep.
Yeah. So the answer is C. Okay. Answer is C for that one. Okay. All right. Number 5. What happens to the value of y in the following equation as the value of x increases, where x is a whole number? Okay. All right. They're telling you x is increasing. X is increasing. So let's just try a couple of numbers here, and then we can look at the graph in a minute. What do you want to plug in for x? Pick a number. 2. All right. 2 squared plus 4. 2 squared is?
4.
Plus 4 is? 8. Now let's pick a bigger number for x, because they're saying x is increasing. All right, let's do 6. 6 squared plus 4. 6 squared is?
36.
Plus 4? 40. What's happening to these values? What am I getting? It's getting bigger and, all right, it's going to keep getting bigger and bigger. So if you had to pick an answer, what do you think you would pick? C, positive infinity, okay? And let's look at the graph of it real quick. You can just look up here on the screen if you want. You don't have to type it in this time. X squared plus 4. As your x values get bigger, the parabola is going to infinity. Okay, the parabola is going to infinity. All right, number 6. Which statement is true about the function? The function has a 0. You may remember the other name for 0? Very good, x-intercept. Does this parabola have an x-intercept?
No.
No, so it can't be A. Please write that down, that 0 is x-intercept. All right, this function has a minimum value. Is that the minimum?
No.
Nope.
What is that?
Max.
The max, okay, because it's at the top, that's the max, so it can't be B. The function has a range. What do I want you to think about when you see range? Bottom to top. All real numbers. At the bottom, does it go to infinity? Yes. At the top, does it go to infinity? No, so it's not C. The graph of the function has one y-intercept, okay, and no x-intercepts. So that is true. Okay, that's true. All right, number 7. Scotty is a punter for the football team. Scotty knows that if he can punt the ball high, He knows if he can punt the ball so that it stays in the air for 15 seconds, the ball will go 50 yards high. His teammates can get down the field in time to make a good tackle. Sketch a graph of the punt Scotty makes, determine an appropriate domain and range for the situation. Okay? All right, let's assume he's kicking the ball straight from the ground. We'll just assume that, okay? And let's call this one time. What would you call the y-axis, you think, maybe? Height, good. Okay. Time and height. Okay, so again, we're assuming the ball is starting right here. What's happening to the ball? It's gonna go up. What else is gonna happen to the ball? Is it gonna go up forever? What's the ball gonna do? All right, it's gonna go, and it's gonna come. Let's assume nobody catches the ball. What will happen to it? It'll hit the ground and then roll, okay? But it'll hit the ground first, right? Before it rolls, it hits the ground, okay? What? Right, okay? But we're gonna say, for our purposes, we're gonna say once it hits the ground, we're not gonna worry about it, okay? When does it hit the ground? In 15 seconds, okay? All right, 15 seconds. And how high did the ball go? It went 50 yards high. So over here, I would label that 50, okay? All right, what do I want you to think about when you see domain? All right, I want you to think X, and what else? Left to right, okay? So look at your X values. On the left, where is it at? 0, okay? On the left is at 0, and you will use a bracket for that one. On the right, what's your X value? 15, okay? All right, if you just answered, I want somebody else to answer for this one. Range, bottom to top. And somebody else give me what the two numbers would be. Who hasn't answered yet? Somebody? What's the bottom number? 0. What's your top number? 50 on your Y. Okay. Anybody need more time? All right. Number 8, the expression negative 4.9 t squared plus 17t plus 0.6 describes the height in meters of a basketball. T seconds after it's been thrown vertically in the air, sketch the graph and determine the domain and range in context of this situation. Okay. All right, if I look at this, what do I know? What do I know just looking at that equation? The y-intercept is 0.6. So I'm going to come right here, and I'm going to say that is 0.6. Okay, I know you don't have much room. I'm going to say it's going to start at 0.6. And it's 0.6 meters. All right, what's going to happen to the basketball? And it'll come down, okay?
I think that's terrible.
All right, do we know when it's going to hit the ground? Do we know that information yet?
No.
How could we get that information? Graph it, all right? Go to your Desmos, and we'll type this one in. Negative, 4.9 X. You got to use an X. You can't use the T. Got to use an X.
That does look like
It what?
that does look like
All right, so you got to use an X. Where is it hitting the ground? Where is it hitting the ground?
0.4.
All right, so let me click it. What does it say when I click it? 3.5. All right, we'll round to just 3.5 for that one. We won't round to 3, we won't round to 4, we'll do 3.5. We will use a decimal. So it's hitting the ground at 3.5. What's the one other piece of information I need to know?
Oh, how high it went.
How high it went. So use your zoom out on the Desmos. Use your zoom out good. And click that top point. How high is it going? Be careful. Which one's the height? The 1 or the 15? the 15. So it goes to 15.3. All right, 15.3 is its height. Okay. All right, domain. Somebody in the back, answer the domain for me. Somebody in the back. Left or right, good. Somebody else in the back, the domain. Shh. Nope. I want to know what my numbers are, left or right. In the back. Somebody in the back, yep. 0 to? Right here, 3.5. That's the one on the right. Okay. Good. Range is bottom to top, and it's your y values. What's the bottom for the y?
0.0.
Okay, so it all depends. You can interpret this question either way. If you think that the basketball is going to hit the ground, then at this point it does go all the way down to 0. Okay?
It would hit the net. So
Right,
it's not the ground.
right. So it all depends on how you interpret it, okay? So this one would be more clear on the test. And then what's your top value? 15.3, okay? All right, let's do two more as a class. Number 9, what are the, actually let's stop here and we'll let you do these on your